Hello everyone, welcome to lecture 7 on relay construction and principal operation. Let's try to recap what we have discussed in the previous lecture. The relay is going to act as a sensor to sense the fault, locate it, and sends the command to an appropriate circuit breaker to isolate the faulty section, thus keeping the rest of the healthy system functional. Right. So in the protective relays, it is broadly classified into three types: electromechanical relay, static relay, and numerical relays. So most of the relay in service on electric power system are of electromechanical relay, and they work on the principle of electromagnetic attraction and electromagnetic induction. Now, when we look at the types of electromagnetic relay, there are two types. One is the attracted armature relay, and the second one is the induction relay. Right. So, under the types of attracted armature relay, we have different types. So, last class we have discussed about hinged armature type, plunger type, and the balanced beam type. So before going through the explanation of these three type of relay, let's try to visualize once again how exactly that electromechanical relay is going to work, on what basis. So here you will be having one iron core. On that you will be wanting some coils. Once that coil is energized, or if the operating current becomes larger than the preset value, so the magnetic field will try to attract that armature or the plunger, making the contact with the trip circuit so that it can close the circuit breaker. So here we can see that there is a kind of electromechanical relay. So on the right side we have a iron core, on this we have coil, and on the left side we have a bulb connected, and there is a movable contact on both the sides. So once circuit is closed, saying that once the current exceeds a certain preset value, it will get closed. So this will get energized, and it will try to attract this armature, and it will close the circuit, making sure that the bulb is glowing. So you can just check it out. First it will get closed, second it will energize, and third part is it will try to attract, or to try to close the contacts. Once it closes the contacts, the bulb is on. Again, it is a kind of a similar concept of an armature attracted relay. So again, this is a software core on which we have coils wounded, and these are the fixed contact. This is a moving contact, and this is the armature. Now it is non-energized, in the sense there is no current flowing in this particular coil. So these coil are connected to the circuit, the current transformer, right? These are the secondary turns of the current transformer. Now once the current exceeds a certain amount of limit or the preset value, it will get energized. It will act as an electromagnet. Then it will try to pull this armature towards the electromagnet. So this is how the contacts get closed, or this is how the armature closes the contact. Now, as I discussed, there were four parts in the relay. One is the electromagnet. As we can see, that this is an iron core, and we have coils mounted on that. And when we give supply, it will act as an electromagnet due to the flow of current. And armature, which is a moving part in the relay, and which opens and closes the contact. A spring is attached to the armature so that can retain back to its original position. Contacts, there are two states. One is closed state and one is open state. Closed state of contact means electricity can flow between them, and when it is open state, it means contacts are separated and the switch is non-conducting. Here, the spring is attached to the armature of the relay as discussed, which helps in returning the armature to its original position. So let's try to see recap what is hinged armature type. So as I have shown you the previous figure wherein you have a iron core, on this you have coils, and to this the some operating quantity has been supplied to that. If that quantity exceeds a certain limit, this will act as an electromagnet. Because of this, there is a flux produced in this, so this will act as an electromagnet. So because of this, the armature is going to attract this particular electromagnet. So once it does, it will try to attach with the fixed contact. So this is the moving contact and this is the fixed contact. If it get energized, then only it will attract towards the electromagnet. If not, the spring will try to hold that movable armature. So here the electromagnet is going to carry some coil, and the coil is energized by some operating quantity, and the armature or a moving iron is subjected to magnetic force produced by that operating quantity. Now the force is proportional to the square of the current. Here, the whatever force by which the moving armature try to attract the electromagnet is proportional to the square of the current. Now, a spring is used to produce the restraining force or a torque. Now, when the current through a coil increases beyond the limit under faulty condition, the armature gets attracted to the fixed contacts. Due to this, it makes contact with the contacts of a trip circuit, which results in opening of a circuit breaker. Plunger type. Now, in this relay, a solenoid and an iron plunger which moves in and out of the solenoid is to make and break the contact. So this is the plunger, movable iron plunger, which is going to move in and out of the electromagnet. So this is the electromagnet, right? So the movement of the plunger is controlled by a spring over here. If a fault occurs, the current through the relay coil becomes more than the pickup value, causing the plunger to attract to the solenoid. So the upward movement of this plunger is going to close the trip circuit, thus operating the circuit breaker and disconnecting the faulty circuit. The third one is the balance beam type. It consists of a beam which carries two electromagnets at its end. One is the operating coil and the second one is the restraining coil. Now when the operating coil current exceeds the restraining coil current, the armature fitted at one end of the beam is pulled and contacts are closed. It means that whenever a fault takes place, the current through the relay coil becomes greater than the pickup value, that is the preset value, and the beam is attracted to close the trip circuit, which causes the opening of the circuit breaker to isolate the faulty circuit. So always the operating coil current will be greater than the restraining coil current, then only the armature is going to close the contacts. Now we'll be looking at the fourth relay, that is the moving coil relay. It has two types of relays. One is the rotatory moving coil and the second one is the axial moving coil. Now this is a permanent magnet moving coil relay. This is a permanent magnet moving coil relay. Why? Because this outer part is a permanent magnet. It is not an electromagnet now. It responds to only DC actuating quantities. It means that it will take only DC quantities such as the current. It can also be used for AC while with the use of rectifiers. Now these moving coils are most sensitive type of electromagnetic relay, and these are more costlier than the induction cup. So let's try to see how does the rotatory moving coil works. Now the figure shows the rotating moving coil construction. The components are, this is the permanent magnet, a coil wound on a non-magnetic former. So this is the, here there are coils wounded on the non-magnetic former and an iron core and a phosphorus bronze spiral spring to provide the resetting torque. So there will be a spring which is attached to this particular moving contact and also a spindle. Now when the coil is energized by the fault current, so the coils are present on this non-magnetic former. Now when the coil is energized by the fault current, due to the interaction of the permanent magnetic field produced by the permanent magnet and the field produced by the coil, the moving torque is developed. Due to this, the spindle will rotate and closes the trip circuit. Now, as the flux density increases, the less current is required to produce the required force. So here you can imagine this is acting like an induction motor. So this is a permanent magnet which is going to produce a constant magnetic flux, right? And this is a non-magnetic former on which we have coils mounted, and this is connected to a spindle. And this is the moving contact. This is a fixed contact. So it is just like current. When the current exceeds the certain limit, or whenever the fault occurs in this particular coil, right? So current, it is going to carry some current. So current carrying conductor placed in a magnetic field will experience a force or a torque. So here the force is directly proportional to the number of turns on the non-magnetic former, the flux density, the current in the coil, and the length of the coil. Again, this is the general description about the rotating moving coil and the working of the rotatory moving coil type relay. Axial moving coil relay. So the figure shows the construction of an axial moving coil type. So here there's a permanent magnet of C-shaped. There is an axially suspended coil which is wound on a non-former material. Now when the coil is energized by the current, the field, it is going to produce a magnetic field. And this magnetic field is repelled by the field which is already existing by the permanent magnet. Due to this, the contact gets closed. Now these relays are more sensitive and faster than the rotating moving coil relay. And its operating time of the order is of 30 milliseconds, which can be obtained. Sensitivity as low as 0.1 megawatt, which can be also obtained. This is the explanation for the axial coil. Next is the polarized moving iron relay. So this is a figure for this. So the figure shows the polarized moving iron relay. The construction shown in the figure is a flux rotor current, whereas the magnet shifting attracted armature type construction. Here the polarization increases the sensitivity of the relay. A permanent magnet is used for the polarization. The permanent magnet produces flux in addition to the main flux. So here there are two things. One is the permanent magnet and one is the iron core, which is on which there are coils wounded. So permanent magnet is going to produce its own flux. At the same time, there is one more flux produced from the particular coil. And it is a DC polarized relay meant to be used with DC only. It can also be used with the AC by using some rectifiers. Again, on the basis of Based on the principle of attraction, if the current exceeds the certain limit, this will become an electromagnet. As it is also, as this is also an electromagnet, a permanent magnet, the armature will try to come in contact with the trip circuit. The next one is the reed relay. It consists of a coil and a nickel iron strip sealed in a closed glass capsule as shown in the figure. Here the coils are surrounding the reed contacts. So this is the reed, this is the contact opening. Now when the coil is energized, a magnetic field is produced which causes the reed to come together and close the contact. The reed relays are very reliable and are maintenance free. They can be used as a protective relays. Thank you. So we have seen the different types of attracted armature relay. In next lecture, we'll be looking at the types of induction relay.